The universe is expanding, and that expansion is accelerating. But what if this acceleration itself were to speed up? What if the very fabric of space-time were to tear apart? This is the chilling scenario known as the Big Rip, a hypothetical end to the universe that's both fascinating and terrifying. Imagine a universe where the mysterious force we call dark energy isn't just pushing everything apart, but doing so with increasing ferocity. In this scenario, the expansion of space accelerates faster and faster, eventually overwhelming all other forces. Galaxies are torn apart, then solar systems, planets, and eventually even atoms themselves are ripped to shreds. The concept of the Big Rip stems from our observations of the universe's expansion. We've known for decades that distant galaxies are moving away from us, and in the late 1990s, astronomers made the shocking discovery that this expansion is accelerating. Something is pushing the universe apart with increasing speed, and we've dubbed this unknown force dark energy. But what exactly is dark energy? Well, to be honest, we don't really know. It's one of the biggest mysteries in modern cosmology. What we do know is that it acts like a form of energy inherent to space itself. The more space there is, the more dark energy there is, pushing things apart even faster. In most models, dark energy is assumed to have a constant density. This leads to a universe that expands ever faster, but in a relatively gentle way. Galaxies like our Milky Way would remain intact, held together by their own gravity. It's only on the largest scales, in the vast emptiness between galaxy clusters, that dark energy would win out. But what if dark energy isn't constant? What if its density increases over time? This is where things get really interesting and potentially catastrophic. If dark energy's strength grows, the acceleration of the universe's expansion would itself accelerate. This is the key ingredient for the Big Rip scenario. In a Big Rip universe, the expansion eventually becomes so violent that it overcomes all other forces. About 3 months before the end, galaxies would be torn apart. 3 minutes before the end, planets would be ripped from their stars. In the last fractions of a second, atoms themselves would be torn to pieces. Finally, space-time itself would be shredded into whatever fundamental units it's made of. It's a dramatic end to the universe, but is it likely? Most cosmologists don't think so. Our current observations suggest that dark energy behaves more like a cosmological constant, a fixed property of space. But we can't rule out the Big Rip entirely. The nature of dark energy remains one of the biggest open questions in physics. Studying these extreme scenarios isn't just an exercise in cosmic doom and gloom. It helps us understand the nature of space, time, and the fundamental forces that shape our universe. By pushing our theories to their limits, we can gain insights into the basic fabric of reality. The Big Rip also raises profound philosophical questions. In a universe doomed to tear itself apart, what meaning can we find? How does the potential finitude of existence shape our understanding of life and consciousness? But let's not get too gloomy. Even if the Big Rip were to happen, it would be incredibly far in the future. We are talking tens of billions of years from now. The Sun will have long since swallowed the Earth before we even need to worry about the fabric of space tearing apart. In the meantime, the study of cosmic expansion and dark energy continues to push the boundaries of physics. We are using ever more sophisticated telescopes and experiments to probe the nature of the universe on its largest scales. From mapping the cosmic microwave background to studying the light from distant supernova, we're piecing together the story of our cosmos. And who knows? Perhaps as we unravel the mysteries of dark energy, we'll discover new and even stranger possibilities for the fate of the universe. The Big Rip is just one potential scenario in a cosmos that never ceases to amaze and surprise us. So the next time you look up at the night sky, remember that you're witnessing a universe in motion. Those distant pinpricks of light are rushing away from us, carried on the tide of expanding space. Whether that expansion will gently continue forever or eventually tear reality apart remains to be seen. But one thing is for certain: the cosmos is far stranger and more wondrous than we ever imagined. The universe is expanding, and that expansion is accelerating. We don't know what's causing this acceleration, but that hasn't stopped. Thus, from giving it a name, we call this unknown influence dark energy. But what if dark energy isn't constant? What if it's increasing over time? This could lead to a scenario known as the Big Rip, where the very fabric of space-time tears itself apart. Imagine a universe where the expansion is not just accelerating, but the acceleration itself is accelerating. This might sound like science fiction, but it's a real possibility that cosmologists are considering. In this scenario, the force of dark energy would become so strong that it would overcome all other forces in the universe, including gravity. The Big Rip hypothesis suggests that as the universe expands faster and faster, it would eventually reach a point where the expansion becomes so rapid that it rips apart everything in existence. First, galaxies would be torn apart, then solar systems. Eventually, even atoms themselves would be ripped to shreds. But how could this happen? To understand, we need to delve into the nature of dark energy. Currently, we model dark energy as a cosmological constant, a fixed amount of energy in every region of space. As the universe expands, there's more space, so there's more dark energy overall. This leads to accelerating expansion. However, if dark energy isn't constant, but instead increases over time, the effects could be far more dramatic. The acceleration would increase exponentially, leading to a runaway expansion that nothing could resist. Not even the strongest gravitational bonds could withstand this cosmic onslaught. Let's visualize this process. Picture our Milky Way galaxy, a vast spiral of stars and planets, held together by gravity. In our current understanding, dark energy has little effect within galaxies. The gravitational bonds are strong enough to resist the expansion, but in a Big Rip scenario that would change. As the density of dark energy increases, it would start to overcome even these strong gravitational bonds. We'd see the outer edges of our galaxy begin to fray, stars being pulled away into the expanding void. The night sky would change dramatically, with fewer and fewer visible stars as they're torn away from us. But it wouldn't stop there. As the expansion accelerates further, even our solar system would feel the effects. The outer planets would be the first to go, ripped away from the sun's gravitational influence. Then the inner planets would follow, Earth included. Our planet would be torn from its orbit, cast adrift in an ever-expanding universe. Yet even this cosmic destruction would be just the beginning. As the Big Rip progresses, it would affect smaller and smaller scales. The Earth itself would be torn apart, unable to hold together against the overwhelming force of expansion. Mountains would crumble, oceans would boil away into space, and the very ground beneath our feet would disintegrate. But the destruction wouldn't stop at the macroscopic level. The Big Rip would continue down to the atomic scale. Molecules would be ripped apart into their constituent atoms. Then atoms themselves would be torn asunder, electrons ripped away from nuclei. Even the fundamental particles that make up protons and neutrons would be separated. In the final moments before the Big Rip, space itself would be expanding so rapidly that light couldn't travel between neighboring points. The universe would become a sea of disconnected points, each one causally separated from all others. Reality as we know it would cease to exist. The timescale for such an event, if it were to occur, is far in the future, billions of years from now. But the possibility raises profound questions about the nature of our universe and its ultimate fate. Will the cosmos expand forever, slowly cooling into a vast, empty void? Or will it end in a dramatic Big Rip, tearing apart the very fabric of reality? These questions drive cosmologists to study the nature of dark energy with ever-increasing precision. By measuring the expansion rate of the universe at different points in cosmic history, we can try to determine whether dark energy is truly constant or if it's changing over time. Current observations suggest that dark energy is remarkably consistent with a cosmological constant, but our measurements aren't perfect, and there's still room for alternative models. Some theories propose forms of dark energy that could lead to a Big Rip scenario, while others suggest the opposite, that the acceleration might eventually slow down or even reverse. The study of dark energy and cosmic expansion isn't just abstract physics. It's a quest to understand the fundamental nature of our universe and its ultimate destiny. Are we living in a universe that will expand forever, slowly fading into darkness? Or are we headed for a more dramatic end, where the very fabric of space-time is torn apart? As we peer deeper into space with more powerful telescopes and more sensitive instruments, we're gathering data that helps us refine our models of cosmic expansion. Each new observation brings us closer to understanding the true nature of dark energy and the fate of our universe. The possibility of a Big Rip scenario, while extreme, serves as a reminder of how much we still have to learn about the cosmos. It challenges us to think beyond our everyday experience and grapple with the vast scales of space and time that shape our universe. Whether the universe ends in a Big Rip, expands forever, or follows some other cosmic fate, one thing is certain: the journey of discovery is far from over. As we continue to explore and understand the mysteries of dark energy and cosmic expansion, we're writing the next chapters in humanity's grand cosmic story. So the next time you look up at the night sky, remember that you're not just seeing stars and galaxies, you're witnessing the ongoing expansion of the universe, driven by the mysterious force we call dark energy, and in that expansion lies the key to understanding the ultimate fate of everything we know.